Okay.
Good morning, all. This is a session on agriculture and fisheries in 2030. This session we have three presenters: Dr. Susan-Singh-Renton from the Caribbean Regional Fisheries Mechanism, Mr. Kistian Flemming from the Caribbean Agricultural Research and Development Institute, CARDI, and Dr. Rankine from the Mona Studies Group, Climate Studies Group, Mona. We have three presentations today, and what I'm going to do is introduce the presenters. First, we have Dr. Singh-Renton, then Mr. Kistian Flemming, and Dr. Rankine. So I will first introduce Dr. Susan-Singh-Renton, who will start. And I'll just give you a brief profile on Susan. Susan-Singh-Renton holds a PhD in fisheries biology and is the Deputy Executive Director of the Caribbean Regional Fisheries Mechanism. Susan's research interest is in fish population ecology, and she's worked in the regional arena for nearly 30 years. Susan is an advisor and negotiator for CARICOM countries on tuna fisheries management since 1992, with a history of significant successes in securing internationally approved fish catch quotas for our countries, and also for removal of illegal fishing sanctions. For 10 years, Susan spearheaded CRFM's fisheries science process, which generated advice for managing major commercial fisheries such as shrimp, Caribbean spiny lobster, and cream conch. This activity was key and was used by some countries to successfully gain Marine Stewardship Council certification and international label, enabling higher prices for fish products. Susan's portfolio also includes design and delivery of courses in statistics, fisheries assessment, value chain management, monitoring and analysis of climate change impacts. Since 2012, Susan coordinated the fisheries component of regional initiatives addressing cross-cutting issues in the area of health and food safety standards, seafood commodity development, and climate change. I would now like to hand over to Dr. Susan-Renton. Susan, you'll have to share your screen and go right ahead with your presentation. Just one housekeeping note. The three presenters will make their presentations. I will then ask some leading questions to the presenters, and then we'll open the forum for questions and answers.
Les trois intervenants feront leur présentation et ensuite.
Susan.
Okay, thank you. Thank you, Dr. Robin, and good morning to everyone. And thank you very much for joining this session. We appreciate the attention and your presence here and participation in this morning's session. I'm here to talk to you about the marine subcomponent of the pilot program for Caribbean resilience and what the Caribbean Regional Fisheries Mechanism was able to achieve under the Caribbean Regional Track. I want to remind you, there was a very famous calypso, Seawater and Sand, All We Are is Seawater and Sand, sung by one of my favorite calypsonians, the mighty Chalk Dust. And it was, well, he called it the Caribbean Road March, and it was about, you know, togetherness. It was making the point that, you know, we need more togetherness because we really are all sort of equally vulnerable. I just want to take this opportunity at this point to just draw some characteristics about the marine fisheries in particular as we move forward in the discussions. One thing to recall is that marine fishes is you know, really promoted as a health food. It's very important, you know, evidence has shown that it improves brain function, heart health, etc. It's loaded with lots of useful minerals and good fats and so on. It also forms many of our national dishes. You know, jackfish and breadfruit in St. Vincent and the Grenadines, flying fish and cuckoo, you know. We might be actually moving away from these traditional dishes, but they are our traditional dishes at the moment. And for some of our countries, we have a very high per capita intake of fish. In addition, many of our fisheries are small-scale fisheries. They employ a lot of persons, and these persons also rely heavily on these fisheries as a source of protein. So for the rural and coastal peoples, it's very important source of employment and food. It's a renewable resource. And this is also an important characteristic to remember going forward in the discussions. If we treat it well, it will regenerate, and we can have it all the time if we are able to maintain that regeneration feature. Our industries are currently open access. So sometimes when other sectors fail, persons seek temporary employment opportunities in the fishing sector. This has its pluses and it has its minuses as well. There are many non-climate stresses on fisheries. We face overfishing and poor practices. There's an estimate of about up to 30% of our fish being caught illegally and sold through illegal operations. And this is robbing the legal industry of income in a way, and also damaging the fisheries. It also faces, we know that we face habitat degradation. We have issues of pollution in our oceans. And I'm sure everybody remembers about lionfish, and it's still with us. Lionfish has been a major invasive species, but it's not the only invasive species that we have to deal with in the marine environment. Climate is changing our seawater and sand. You heard, if you listened to Professor Taylor's wonderful presentation, we have more frequent storms, and we're going to be experiencing this more and more. A lot of damage to our equipment, our materials, our infrastructure, and this is going to have consequences for adaptive capacity. Coral bleaching due to warming oceans, and mangroves also at risk. So climate change is bringing additional stresses in the form of warmer seas, sea level rise, our oceans are becoming more acid, we are having a more salty ocean, and this also, all these things are linking up to actually create a less suitable environment for primary production, and that is like the you know, at the very base of the marine food web. For the marine subcomponent, we had two assignments, and the first one dealt with development of an early warning and emergency response system for fishers. So it was a service and a tool that we tried to create for adaptation and dealing with more intense conditions at sea. And the second activity is developing our knowledge base, our information and knowledge base, because in fisheries, we don't currently have, or we didn't before the PPCR, have a lot of information about what impacts to expect. So we conducted both ecological and socioeconomic assessments, and also worked to develop an associated monitoring system. Let's look at the Fisheries Early Warning and Emergency Response System. This was in effect an ICT solution, and we worked with experts from UWI, St. Augustine campus, and they developed the software. And this software is basically, there were two components, a mobile application and a web-based administration dashboard. And specifically, it is to, just reduce the risks that fishers face, reduce risks of damage, reduce risks of loss of life, and just be able to be more ready for emergencies. So small-scale fishers, the primary users, would access the FEWA application through their mobile phone, and we also have agencies on the ground at the country level and also at the regional level, managing the ICT solution through the web-based component. The activity was lasted just over a year, about a year and a half, I would say. And of course, in order to provide a solution that was meaningful, it involved extensive consultations with both the fishers and various agencies in countries. The various agencies, of course, if you're dealing with early warning and emergency response, it would not just be the fisheries authorities, but it would be the meteorological services, the emergency management services, the rescue services, and so on. A number of outputs came from the FEWA. I mentioned about the ICT solution, the software being developed by our UWI consultants. The extensive consultations that took place in 4 countries where this was piloted. These 4 countries are in the Eastern Caribbean. And this led to the development of draft interagency agreements within these countries. Training was provided for both the fishers and the administrators in using the system. And of course, this was to make sure that this is sustainable. We developed manuals for users and administrators. So when there's a staff turnover, the information and the services are not lost. In addition, and I'm just showing you a couple of the reports there, the user manual, and very importantly at the regional level, CRFM formalized an agreement with our regional emergency management agency, SEDEMA, to work together for the global administration delivery of FEWA. So at this time, I'm pleased to advise that the CRFM SEDEMA agreement is advancing. Our UWI counterparts continue to work with SEDEMA, and we're in the process of transferring the hosting infrastructure for FEWA. And so FEWA is expected to be expanded to additional countries. And I'm also pleased to advise you that St. Lucia, which was one of the pilot countries, recently officially launched FEWA at the national level in that country. Let's take a look at the impact assessments and monitoring activity. This had 4 components to it. First of all, we did analyses to determine the determine the impact of climate change on the fisheries resources, the development of the monitoring system, which looked at tools and methods, development of a portal where we house the data and information, and training. There was also a training activity. Stakeholder engagement. This was important because we recognized that there were disconnections. How the fishers thought about climate change, their priorities for climate change were a little different from the priorities of the policymakers and the policy advisors. So we listened to them, and based on the information that was generated by the impact assessments, we created knowledge products to bring everyone on the same page. And also using the information that we generated from the impact assessments and also the CRFM experiences and progress that we had made in promoting issues pertaining to climate change and development of disaster risk management for the sector, we developed an updated strategy and action plan. And this just shows you some of the products. And this portal is, you can find this portal on the web. I just want to share with you a little bit detail about the impact assessment results. And this slide shows the future conditions in terms of sea surface temperature. On the left side is a low carbon emission scenario. So vertically on the left side, the two panels, low carbon scenario. And on the right hand is a high carbon emission scenario. And the top two are showing for sea surface temperature, and the bottom two panels are showing for sea bottom temperature. And of course, for sea surface temperature, you can see changes are more throughout the ocean areas. But in both cases, both scenarios, you are seeing increases in sea surface temperature. And of course, for the bottom panels, you can see that there are it's much more prominent, the increases, the projected changes that we expect for sea surface temperature. It is not us only who feel the heat. Fish can sweat too. And the assessment showed that the climate risk index, it estimated it for 106 species, and the panels there show the average climate risk index. And you can see that for a lot of the species, in the coastal areas and some offshore areas as well, we are looking at figures that are over, around 65 and more. So the yellows and the reds are what you pay attention to. And climate risk index is just building in. We consider things like the fish vulnerability, and this is like species biology and its ability to adapt, its adaptive capacity, and its degree of exposure to hazards. And we have hazards that imposed by climate, and we have hazards that are imposed also by overfishing and illegal fishing and so on. Just one example of habitat suitability. Now, habitat suitability looks at a combination of environmental conditions that put species in particular areas, and that's how we get them, we find them in particular areas. The habitat is suitable. And this shows you here, this picture shows you suitability, habitat suitability for dolphin fish during the period 1970 to 2000. And the yellows show, of course, very good habitat suitability. And in the coming years, it's estimated, by 2030 and by 2050, the low carbon scenario is to the top right, and the higher carbon dioxide emission scenario.
Susan, I have to interrupt you, but you're going over time.
Okay, so I have to try and hurry up. Okay, so basically you can see exactly where the habitat was suitable. It's going to become unsuitable. And so we'll be speaking about the uncommon dolphin fish. Very quickly, just to indicate here, the top panel show you the species extinctions, the blues, the deeper blue, greater extinctions, and so you can see the areas to be affected there. The lower panel show you the species gains, but the main message is that the extinctions are greater than the gains, so we will be dealing with less biodiversity. Put these together, sea surface temperature, sea bottom temperature, all these different changes, even in scenarios of low, strong mitigation, we are going to see a drop in the maximum catch potential by about up to 15% by the 2030s and up to 30% by the 2050s.
Sharon, you have to wrap up now.
Okay, so I will skip this slide. This was just basically to show you that, just to point maybe to the red columns, that overfishing is contributing heavily to vulnerability and the risk index of climate change. This chart, this slide, just shows you some of the knowledge products. We created a video documentary and posters with key messages. And the key messages are really sustainable fishing, adaptation of our methods, diversifying methods, zero wastage, and value chain management. This is my last slide. Just to say, this is our updated strategy and action plan, and it is directly linked with the CARICOM regional framework for development resilient to climate change. So thank you for that. So we are looking at even more seawater and less sand. Sorry to be over time. Thank you.
In the interest of time, I'm going to introduce Kistian Flemming so he can start his presentation. Kistian has been employed at the Caribbean Agricultural Research and Development Institute as a climate change and development specialist since September 2016. He works at the intersection of climate change science, food security, and the development of smallholder farmers and rural livelihoods. He's particularly interested in the interdisciplinary and participatory methods and approaches to confronting complex issues resulting from both biophysical impacts of climate change and socioeconomic environments in which people exist. Colleagues, I now introduce Kistian Flemming, and Kistian, over to you.
Thank you, Greg, and good morning, colleagues, all participants, those who are on the call. I want to just thank the organizers for this invitation and this space to share our perspective as an institute, the Caribbean Agriculture Research and Development Institute, on climate change and its impact on the agricultural sector in the region, and what should our responses look like at multiple scales. So I want to jump right into my presentation, not even spend time on the outline, and begin to speak about the impact of climate change on the sector. And I really don't want to go through too much of what was already shared this morning. I think Professor Michael Taylor did an excellent job. But just to point out in my presentation some additions. I think one of the things that was stressed in Professor Taylor's presentation that I echo is the unprecedented nature of the environment that we are facing. And therefore, it is beyond that which we saw in the past. So yes, there's the physical and biophysical impact, but I think one of those notions that I echo is the impact on livelihoods as well as the well-being. More and more, you see headlines like these in which, apart from the physical impact of these natural disasters that come from climate variability and climate change, you see a sense in which there is other factors that are going riveting through the entire sector, and those things tend to be underappreciated or underestimated, and those things are like the psychological factors, the social factors. Remembering that people are being affected by these things and not just the physical landscape. I have another news article here, and one of the things I wanted to highlight, and again to drive home the point of the unprecedented nature of what we are facing. Flooding isn't a new thing for Trinidad and Tobago, for example, and in this particular agricultural community in the southern part of the country, you do have familiarity with flooding. But I highlighted the date in this article, which indicate that it is March of this year, in the middle of the dry season, in which you have a flooding to the degree and to the scale in which an entire agriculture community was directly affected. Climate climate change exacerbates already our pre-existing vulnerabilities. You know, it doesn't occur independent of the environment that we live in. Again, that was stressed. There is the notion or the climate of food insecurity right through the region, in which many of the Caribbean territories, many of the island states are heavily dependent on food, food import, that is, have a sector that is developing to a large extent. They face different financial burdens. And of course, as an example, we are, all of us, under an era in which a global pandemic is all around us. So the impacts that we face from climate change, as I said, isn't neutral of the environment and in pre-existing conditions, and therefore the impacts that we receive from the biophysical impact that we receive and we get from climate exacerbates these already existing conditions. One of the things that we are particularly we can recognize in the Caribbean is the idea of when we do have climate impact, oftentimes it creates cascading effects on our economies. One particular scenario that is very common, at least here for the small islands of the OACS, when there is a hurricane of a great category 4 and above, and even lower, you tend to see the ripple effect, or a perfect storm, really, is the best way of describing it, in which there's damage to local food production. There's a halt in food imports. The vessels that do bring food commonly aren't able to come to the shores for quite a long time. And one of the other sectors that are heavily dependent by these small island states is the tourism sector. And of course, when you have one of those phenomena passing through the Caribbean, it tends to put some sort of decline on tourism. But remember that climate impact and hazards on the whole, the vulnerability to them is a function of not just the exposure and the sensitivity of the sector, but as I indicated before, there are pre-existing conditions, and some of those that people face tend to be non-biophysical, not just their exposure and sensitivity, but also their limited adaptive capacity. And these are, for many reasons, socioeconomic conditions, their marginalization due to whether it is the landscape, political landscape, or the cultural landscape, or one thing or the other. They are isolated, and therefore they're not able to access measures or resources that would help to improve their adaptive capacities. I highlight here a recent consultation that took place here in St. Kitts and Nevis, in which we sought to find out from the farming community what are the constraints to implementing climate smart agricultural practices. Given that there's so much work that was done in terms of highlighting what climate smart agriculture looks like, and apart from that, just resilient practices on the whole. And one of the interesting things that came out of that session was the amount of time farmers spend in various activities. But I want to highlight these three. I circled them, and it attests to, again, the idea that people exist within conditions that sometimes don't necessarily align with the priority of climate, the impact, as well as the need for us to respond. So for example, when we looked at the constraints, we highlighted, or one of the things that came out is the amount of time is spent on doing things other than implementing climate smart agriculture practices. And one of these things that jumped out here was a lot of time was spent on monkey management. And if anyone know about Cincus and Nevis and some of the problems that the sector faces, one of the greatest is the impact of the green vervet monkeys. But what was highlighted was so much time is spent on cooking food or putting preparation into controlling the impact of monkeys, that there really isn't much time left over here to attend meetings that would help to, to improve adaptive capacity or even to implement some of the climate smart agriculture measures. And these are some of the things that we need to take into consideration when we are looking at how a person perceives the impact of climate change, and especially when we are trying to arrive at intervention points into these different contexts. I just want to spend some time on what has our response been as a...
Speed it up a bit. Can you speed it up so that we can give the floor some time to ask questions?
Sure. Some of our response has been on one of our key areas is on the identification, characterization, and really promoting the use of climate tolerant crop varieties. There, under the PPCR project itself, there have been some work in evaluating and characterizing key commodities, and in particular, there was a drought study done or being done on sweet potato at the CARDI field station in Mona. Other various units have been involved in maintaining germplasm, again, with the idea of making, identifying those that have shown signs of tolerance and making those available to the sector, to the farming community for their use. Another key area is the use of climate information services, integrating these into our production and other practices in this sector that would help to support resilient practices and innovations at multiple scales. And one of the last key areas is utilizing protected agriculture. Again, Professor Taylor stressed the idea that there is an unprecedented climate, and we are going to be left with such a climate for a while to come. And therefore, a rationale is perhaps we need to be looking at some unprecedented solutions, things that we haven't seen in the past or isn't necessarily common to our landscape. And one of those things that we have been piloting here in CARDI is the use of different hard structures that could offer some resistance to hurricane conditions, that we could utilize, control environment, agriculture, so that we are able to have a production system and production models that are least interrupted, both by, on one hand, drought conditions, dry conditions, as well as the hurricane season, flooding, the incidence of pests and diseases. What should a regional response look like if we want to have a resilient sector? I think that needs to be integrated and empirically driven. Again, when developing, if we are looking at developing resilience in the sector, that need to be integrated and it need to be informed by research. The policies must be driven by research, and that policy must be geared towards stimulating resilient practices and investments, and not a business as usual scenario. Vulnerability is complex. It isn't just a function of biophysical hazards, but it involves people, and it therefore needs novel solutions and approaches to arriving at interventions and solutions into that we expect people to practice. I think we need to revisit the regional plans and policies. We have a lot of them, and they are a wealth of resources and measures that were already identified, and some of these I think we still aren't doing, and we need to get back to them. And I will just end on this note and leave this picture here of some of these policies that I think are still worth helping us and revisiting. Thank you very much.
Thank you very much, Kistian. Let me introduce our last speaker for this particular session, Dr. Dale Rankine. He's an applied climate scientist in the Department of Physics at the University of the West Indies, Mona. He holds a PhD in physics and worked as the agricultural climate modeling research analyst under the regional track of the pilot program for climate resilience. That's the PPCR project. His research interests are climate and crop simulation modeling, and more broadly, assessing climate change impacts on socioeconomics of Jamaica and the wider Caribbean. Colleagues, Dale Rankine. Dale, please go ahead.
Thank you very much, Mr. Chair, and good morning to all. It's an honor and a privilege to be here as part of the panel. I want to thank the PPCR for the opportunity to be part of it and to share in the very rich discussions.
Dale, you have 10 minutes.
Yes, Mr. Chair, I'll try and use 8. Okay, so I want to look at a particular subsector of the agriculture sector. In this particular case, I want to look at the whole notion of crop yields and how do we go about improving crop yields, the prediction thereof. Let me just say that, just piggybacking on what Professor Taylor mentioned this morning, we've seen how difficult and the challenges that we're having with both unfamiliar and unfavorable climate. And of course, this is having significant adverse impacts on our ability to continue to produce, both in terms of the viability and the reliability of it. Of course, when this is affected, it also affects our food security and all aspects of food security. One of the things that we find interesting is that whenever you have any event, any climate event, it has a cascading effect on agricultural production. I'm going to use the case of Jamaica just to make a point here. For example, you see in this graphic, it actually shows what happens to agricultural production. This is an index that is used. You will see whenever we have no impacts, whenever we have no major events, the index goes up. As soon as we have a drought or a hurricane or any adverse weather phenomenon, the impact is very, very serious and severe on the production. And so we have this cycle between going up whenever we have no problems, and as soon as there's an issue, we see the adverse impacts. And this is true of nearly any country in the Caribbean. So what is one of the challenges that we have? The farmer, of course, goes to the market and he tries to sell his produce, and he's looking at his yield, what he can get from the field, which is in tons per hectare. This graph here on the left-hand side, that actually shows a measure of yield. In this case, I'm just looking at one root crop just to show you. It is true of pretty much any crop in the Caribbean. But the red shows yields of sweet potato, for example. The black line shows you what we call the standardized precipitation index. Just for brevity, any value above 1 is wet, above 2 is very, very wet. And in the negative regions, it's dry and very, very dry. And you will see, for example, that the graphs are out of phase. For example, here when we have marked variation in rainfall variability and availability, we're having very, very favorable yields. We recognize that this was due to a linear increase, and this really was due to an attempt that was made by the government of Jamaica to increase production in sweet potato. So we detrended the data. And when we detrended the data, you realize that we are having an even more significant problem. When we're having record rainfall, we're reporting very low yields. And by contrast, when we're having high yields, we're having low rainfall. And so we recognize that there certainly is a problem. There is a misfit between the data that is actually reported. And this is true not just for Jamaica, but for other crops and for other countries. The real problem is because the data is out of phase. Most of the data is estimated. It is aggregated across different varieties and time and space. So what we had to do to recognize whether or not there was some kind of trend in the data was to do what we call a wavelet analysis. simply put, this is a cone here. Anything inside the cone is significant. The darker colors show whether there is a very strong relationship. The blue color show the light relationship. So somewhere around a 2, and it tells you what is the period of this variability. So we see a 2 to 7 year cycle in the data. So yes, there is a cycle in the data, but this was looking at area harvested. On the right-hand side of this graph, it shows how strong is this relationship. It is showing that there is a very strong relationship. So immediately we try to find out, okay, so what's the link? The link is that, of course, there's a 2 to 7 year cycle, which is called the El Nino, which affects rainfall. In the year of onset, it reduces it, and it increases it in the year after onset. So we're able to find out that the farmers make an autonomous adaptation. Once rainfall is favorable, they will farm more. When rainfall is not favorable, they farm less. But you won't find it in the yield data, because in most cases, the yield data is estimated. So the question is, can we do something about it? And the answer is yes. I want to introduce you to this software package. It's called the Decision Support System for Agrotechnology Transfer. From hereafter, we call it DSAT. And this is a very useful software program. It uses a number of different modules for weather, takes in your weather data, your management information, takes in information about your planting, your harvesting, or what you're doing in terms of irrigation, fertilization, and so on. It allows you to alter your parameters. So for example, you can test to see what fertilizer is the most effective, when should you irrigate, when should you harvest. You can experiment with planting dates and so on. And at the end of the day, it can also simulate a lot of things. For example, how the plant utilizes nitrogen and so on. So it's a very useful module. It has over 45 different crops. Many of them are grown in Jamaica and in the wider Caribbean. And here is a look of the interface, and it actually shows you, this is an experiment that we actually did, and we're writing a paper on it that shows you a cassava experiment, tells you where the experiment is and the different varieties that are actually being used in the experiment. So just to show you, what we had to do is to go in the field. We had to measure right throughout the plant life, the crop life, not just at the end of the season, but rather throughout the season. We have to take measurements of plant height, what are the branching characteristics, the leaf production, the leaf area index, canopy cover, and so on. Because we want to get a sense of how the model is performing right throughout the life of the crop. And this is very, very important if we're going to improve our yields in a changing climate. Okay, with that said, what do we have to show? Here is a plot of what one of the varieties, this is called the CM849. It's a variety that is actually produced in Colombia.
Ça, c'est une variété qui est produite en Colombie, qui montre les kilogrammes par hectare.
What is simulated. So we were able to capture right throughout the crop life what the model was doing in terms of their total production. In terms of the yield, which is what the farmer actually is interested in, and this is based on dry weight, which is just about 33% of your fresh mass. The model was able to capture quite well what is actually happening in yield. A slight overestimation, but of course, I would say all models are wrong, but some are useful. So this was a useful response and result for us. Okay, now, one of the things that we're able to do with the software is that we can alter the environmental conditions in one of the features called environmental modification. You can change, for example, with having had your climate, you can increase the maximum temperature, decrease the maximum temperature, you can increase the relative humidity, increase the CO2 and so on. So what we did was to create a climate scenario to say, okay, what if we increase the rainfall? What if we decrease the rainfall? This is just one of many scenarios we tried. From say 1,596 in the rainfall season to 958 by 40%, what if we increase the maximum temperature and increase the CO2? All right, so this is just showing an example. What we found, for example, when we didn't increase the CO2, but decrease the rainfall and increase the temperature, we found that there were declines in yields. However, when we increased the CO2 concentration in keeping what we'd expecting about 2080, we found that there was a decrease in the yield losses, all right? And so this emphasizes the beneficial impacts of elevated CO2 on production. Having said that, in the next minute and a half that I have left, let me just say that we have to extend this solution beyond just the farm level, all right? It's very good for us to have it at one location, But we developed this project called ACCEPT, which is Agricultural Climate Change Evaluation for Production, Transformation, and Resilience. And what it is an online portal that says, okay, can we do this kind of work in different locations? And the answer is yes, ladies and gentlemen. All right, and here's a portal. It is online, it's freely available. You can go into crop modeling, and without having all the technical jargons and information, you can select a location. This can be done for any country. For the moment, we're using Jamaica. So let us say, for example, if I was interested in Kistian, I could type Kistian. And when I do that, it actually brings up for me a simulation of what I'm actually doing. And it actually can show you in real terms what expected yield you can actually have. So we find it to be quite a useful initiative that we can actually use. As I said before, it can be expanded beyond just the realms of Jamaica. We think it has Caribbean-wide relevance, and it should be quite useful in that regard. One of the things that it can do, when you select a location, it auto-selects the closest weather station, the soil conditions in the location, and then it gives you an estimated yield of what you can expect. So rather than having unspecific values that are not separated by cultivars, it allows you to do that. And we think it's a very useful start. A number of persons have actually started to use it, and we encourage its continued usage. Then, with that, Mr. Chairman, I will conclude to say a couple of things very quickly. One, that agriculture is inherently vulnerable to climate. A number of what we did, the production regimes that we have are entirely rain-fed without supplemental irrigation. So that current and future changes will have severe consequences unless we take action now. Root crops have exhibited some tolerance to drought. Of course, we know they have trailing vines and so on, and are not as exposed as other crops are. And of course, we have to start doing more modeling to be able to say exactly what is going to happen in a proactive way. We think the ACCEPT portal is a good way of extending the work beyond just the farm level. And of course, further resources are needed to expand and to proactively identify adaptation options. I just want to close with some acknowledgements. These are the persons that made the research possible, and we're very grateful for their support. The PPCR that supported my involvement for over 3 years, and a number of private sector organizations and other groups, including CARDI. Thank you very much.
Thank you, Dio. Now, we do not have much time left. We have about 7 minutes. In terms of the questions to ask the panelists, I went through the chart, and I took a question from the chart, which I thought the three panelists can address. And the question is, how are we coping with agricultural management in relation to climate change? And please, we can put in fisheries here. We can say, how are we coping with fisheries management in relation to climate change? What I want from the panelists, 2 minutes each, is a response about the do's, not what's happening and the threats and so on, the do's. So all this work is being done, the PPCR project, I'm aware of the Climate Studies Group, CFRAM, 1 or 2 pointed do's that the fishing community and the agricultural community can adopt and go on with. I'm assuming that the questions will be answered by the PPCR project as a response from the conference. Okay, so I'll start with you, Susan. 2 minutes.
Thank you.
How are we coping with agricultural or fisheries management in relation to climate change? So what are you doing that can make that impact for the small fishers?
Okay. Well, I think now that we have completed those impact assessments, it has taught us. We know now that the fish distributions are going to change. They are moving more offshore. They're going deeper. They're going further north. So this means that our fishers will need to diversify their gears and their methods. we are also going to, the consumer and the processor also have to become more, they also have to diversify, because we are going to have to, you know, rely less on the commercial species that we know now, and actually develop, you know, markets and demand for different species. The fishers are already seeing this change, but the adaptation is going to be proving tricky, because we learned this from some of the surveys that we did. They are seeing the changes, but they are unwilling to, you know, make the adaptation. So capacity building, this is something that we have to move forward on. Okay, we have our strategy. We have also been working on fisheries insurance. I mean, these are different different areas of work that we have been exploring. We also, the fewer that I spoke about, the fisheries early warning and emergency response system, we are working to expand that to additional countries.
Right.
I can say more, but I know my time is up. So,
Greg, I want to promise my response by saying, as I highlighted in my presentation, that it's the environment and our need to adapt. It's complex. It's a complicated environment. Again, it's not just the biophysical impacts, but there's also the socio-economic, political landscape. So if we simply inform just the biophysical considerations and what the biophysical effects and what we need to do in response to those, without, you know, considering people, perceptions, practices, culture, and Susan mentioned some of them already in relation to fishery. So some of the keywords, key messages, we need to be holistic, integrated, systemic. We need to be looking at why people do the things they do and don't do. What could be clear to some of us, but on the ground, there's sometimes a different reality.
Thank you.
Thank you.
Dale?
Yeah, thank you very much. Mr. Chair, I would just say very quickly, it's time to act. The A for me is adaptation. And I think the adaptation takes into consideration both actions that we have to take, soft measures in terms of policy and so on, but also hard actions that we have to take that involve the use of, for example, things like protected agriculture and so on. The C for me is communication. We have to communicate well with all publics, and also including what are some of the serious challenges that we're facing. We see some of the work that Climate Studies has been doing around the Caribbean as well. We have to have a good communication platform to explain what are the risks that are being faced. And the T for me is the transfer of knowledge and technology, because that is very, very important. It has to get down to the grassroots level for everybody to understand what is required. So I think those are the three basic legs on which I think action should be based. Thank you.
All right. Thank you, panelists. But I just want to make one comment as the moderator. Technology adaptation is key, but there's a cost to it. And what I've been finding is that farmers and fishers, in many instances, cannot afford to adopt the technology. We now have to look at ways and means of facilitating the small farmers and small fishers. Whether it means the word subsidy never sounds well to policymakers and funding agents, but we have to do something to support small farmers and fishers in the climate change era to adopt technology. So thank you very much, panelists, for your very interesting presentations. I think I'm sure the presentations will be made available to the audience spread across the Caribbean and internationally. Good to see you guys again. And I'm sure the conference will continue to be very informative and be a very successful conference. Thank you.
Thank you.
thank you. Thanks for having us.